Hey everybody, this is question number 2 from the fall 2016 exam 1 for Mr. Walsh at Rowan College at Burlington County. And this question has everything to do with the integrated rate law. So let's go over how to solve this so that we know what the deal is. Okay, so the first question says calculate K. Now when we do this, we need to know something about the reaction. Keep in mind, this is not going to be a method of initial rates because what we're given is time in minutes and concentration. We know that concentration and time relationship is the integrated rate law. So in order to solve part A, we have to know what the first order integrated rate law, and it tells us here that it's first order. So the first order integrated rate law, or at least one form, is ln of A at time t, whatever time that is, equals negative kt plus the ln at time 0, the ln of the concentration at time 0. Because we have the concentration at time 0 and any other time, we can do this. So I'm just going to pick time 4. That's just my own personal preference. I like to take data that's further away from the starting point for whatever reason. It's just kind of the way that I operate. Okay, so but it should work. You should get roughly the same answer for any of these times. So the ln of 0.1, oh, sorry, not 0.1. The ln of 4, right? Not what's the constant? I'm screwing this all up here. See, it's it can be challenging. Okay, so at time t, the concentration is 0.0670 equals negative k. And that's what we're solving for. And the time is going to be 4 plus the ln of 0.1, because the concentration at time 0 is that. Okay, so this is where we break out the calculator. So we do ln, and keep in mind that's ln. It's not the log button, but it's the ln of 0.067. Okay, and that's negative 2.70 equals negative k times 4 plus the ln of 0.1. And the ln of 0.1 is negative 2.303. Okay, so now we can add this. Okay, so negative 2.70 plus negative 2.3. Oh, so I'm sorry, we're going to subtract it, okay, because we have to subtract a negative 2.303 from both sides. Okay, so we're subtracting 303, okay. And so we get an answer of negative 0.397 equals negative k times 4. So take away the negative, divide by 4. So divide by 4, and we get 0. We take away the negative, okay, because the negatives cancel. So we get negative 0.0995 equals k. Okay, and then the units, if you really wanted to get into it, are going to be 1 over, and then the unit of time is minutes. Okay, now for part B, it's saying calculate the concentration when t equals 5 minutes. Well, again, we have to use this equation, and now we have a k, and a k doesn't change as long as the temperature doesn't change. So we get the ln of A at some time t equals negative 0.0995. I'm sorry, I'm jumping ahead a little bit. I'm so excited. Okay, equals negative kt plus the ln at the concentration at time 0. So we're solving for the concentration at 5 minutes. So that's going to equal negative 0.0995, that's our k from part 1, times t, 5 minutes, plus the ln of 0.1. Okay, so what is the ln of 0.1? Okay, so that equals, and then what is 0.0995 times 5? So this is negative 0.4975, because it's negative here, we carry the negative down, plus negative 2.303. And so we add that. So negative 0.4975 plus negative 2.303. And so that equals, let me get a little room. So the ln, the concentration of A at time t, equals negative 2.8005. Now we have to d-log this, okay, or d-ln it, okay. You have to do the inverse of this. And so the inverse of log is e to this, okay? And so if we do it to one side, we have to do it the other, so we get the concentration of A at time t equals e to the negative 2.8005. And that equals 0.0608. And that's concentration, so that's molarity. Okay, so now for part 3, we do the same sort of thing, except now we want to know what the time is when the concentration gets down to 0.01 molar. Okay, so again, it's a first order rate equation, so we're going to use the same thing, ln of A t equals negative k t, and that's what we're trying to calculate, plus the ln A naught. Okay, so now the ln in this case is going to be 0.01, because that's the time that that's the concentration at the time we're concerned about. So the ln of 0.01 equals negative 0.0995 times t plus the ln of 0.1. Okay, so the ln of 0.01 is equal to negative 4.61 equals negative 0.0995 times t plus negative 2.303. I can remember that from the problem we did before. So now we add negative, so we have to, we have to subtract negative 2.303, subtract negative 2.303, okay, and so we get negative 4.61 minus negative 2.303, and we get negative 2.307, okay, equals 0.0995 t, and now we divide both sides by 0.00995, okay, that's a negative, okay, the negatives cancel, okay, divide by 0.0995, so we're going to divide that by 0.00995, and we get an answer, oh, negative, but we already got rid of the negative, so we get t equals somewhere right around 23.2 minutes. Okay? So that explains question number 2 on this test. If you have any questions, feel free. Okay? Thank you so much.